Swayam Prabha. Digital India. Educated India.
Hello learners, I welcome you back to our course of microeconomics and its applications, and today we will be into the lecture 3 of the unit 3 which we have been discussing, and the unit is on production analysis. I am Dr. Aparna Samudra from RTM Nagpur University, who is coordinating this course as well as presenting this lecture. So learners, let us see that what all are we going to discuss in today's lecture. As we all know, in the past two lectures of Unit 3, we have been talking about that how does a producer behave under different time periods and how does the production of a firm change with respect to change in the factor inputs which the firm is using. Two types of time periods we have discussed till now, which is short run and long run. And we have seen in short run, the firm has certain variable factors of production whose amount or quantity can be changed, and other are the fixed factors of production. So the law which we discuss in short run with respect to production is called as the law of variable proportion. Thereafter, in the second lecture of this unit, we discussed about the returns to scale, wherein we saw the behavior of the output or the total product. How does it change when all the factor inputs keep on changing? So we talked about constant returns to scale, we talked about increasing returns to scale, and we talked about decreasing returns to scale. And to understand the returns to scale, we had introduced a very important concept of isoconts. So today's lecture, we will be going ahead with the same situation wherein the firm will be talking about what is an iso cost line. Then we will be talking about that how does a producer decide that what should be the optimum combination of the factor inputs it should utilize or engage. And then we will be talking about the expansion path of the producer. Before going ahead with the new concept of ISO cost and expansion path and the producer equilibrium, let me just give you a small recap of the isocons. What were isocons? We had said isocon basically means they are equal product curves, or they are those curves which show the relationship between two inputs, let us say labor and capital, holding the output constant. That is, an isocont is a locus of all the combination of these two inputs, labor and capital, which are producing the same level of output. So this is the graph which we made of an isocont if we are taking labor and capital, and if we are talking about this isocont Y star, this means that all the combinations of L and K which are lying on this isocont will give the same level of output, that is Y star. So this is a brief recall of the concept of isocont. Now let us move ahead with the new concepts which we are going to talk about today, and the first concept therein is of iso cost line. As the name indicates and as I have explained it to you earlier, iso basically means equal. So this line means equal cost line. Let us see what is the formal definition of this iso cost line. We say iso cost line identifies the combinations of inputs the firm can afford to buy with a given expenditure or cost at given input prices. That is, if the prices of inputs are given to you, let us say if a firm is engaging labor and capital, price of labor is given to you because we are saying that it's a small firm which is unable to change the prices of the inputs which it is buying from the market or hiring from the market. So if price of labor and price of capital are given, And also the firm has been given that how much is the budget it has or what is the cost it intends to incur. So all the combinations of these labor and capital which the firm can afford with the given expenditure or cost, that line which we get is called as an ISO cost line. So what does an ISO cost line show us? It basically is giving us the combination of the inputs the firm can afford to buy with the given expenditure or the cost and given input prices. So three things are given. My firm has to take three things from the market, that is price of the factor inputs is given, the cost or the budget is already given to it. Now the firm, by using the ISO cost line, can see that what are the various combination of the factor inputs it can afford to buy with that particular expenditure and the price of inputs in mind. So basically, it shows all combinations of capital and labor that can be hired for a given total cost. That is, if total cost has been decided as, let us say, 10,000 rupees. So, with the given price of labor and capital, what all combinations of labor and capital this firm can afford to buy or hire is given by the ISO cost line. The equation of the isocont line is given like this. C is equal to W into L plus R into K, where C is the total expenditure or the total cost. W is the price of this labor, that is the wages. L is the number of labor being employed by this firm. R is the cost of capital or the rate of interest, and K represents the capital which the firm is hiring. So the equation of the isocost line is C is equal to W into L plus R into K. This means that the total cost which the firm is going to incur is equal to the cost of labor plus the cost of capital. What is cost of labor? The price of labor into the number of labor units I am hiring as a firm. So that will give me the expenditure on labor or the cost on labor. Similarly, R into K shows the expenditure on capital, that is the price of capital given by a small r, which is the rate of interest, multiplied by the number of units of capital the firm is hiring. Now the slope of the isocost line is given as price of labor divided by the price of capital, or W, which is the wages, divided by R, which is the rate of interest. It carries a negative sign showing that the isocost lines are negatively sloping or downward sloping. So slope of the isocost line we can say is price of labor divided by the price of capital. So if we are representing price of labor as wages, so small w is the price of labor, whereas small r is the price of capital. Now you can draw this particular analogy with the same as your budget line of the consumer, which we did in unit 2. So the ISO cost line is of a producer is similar to the budget line of a consumer. Okay, now let us see that how a ISO cost line looks like if the given cost to the firm is of 100. The cost of capital is R is given as 10 and the price of labor is given as 20. So these are the three things which are given to you. The given cost is there as 100. Price of the factor inputs, that is price of capital and price of labor, are given as 10 and 20 respectively. We already know that the isocost line or isocost curve, the equation is C is equal to W into L plus R into K, or it shows the cost of labor plus the cost of capital. Now we will draw this line graphically to see that how does it look like. Now, if you are saying that I am not spending anything on the labor, I am not hiring any amount of labor, this means my cost of labor will become zero. Only thing which I am taking is capital. So this point of intercept, that is C divided by R, total cost divided by the price of capital, will give you the intercept on the K or the y-axis. Similarly, if the firm is only using labor and taking 0 units of capital, then the intercept on the x-axis will be C divided by W. It will give you the number of labor which the firm is going to hire with the given cost and the given price of labor and not using any single amount of capital. So once you get these intercept, which we get as 10 for the K. Why? Because 100 divided by R will give us 10. So you mark it on the y-axis where we are measuring capital. Similarly, when you go to the labor axis, that is the x-axis, you are dividing your cost by wages. So 100 divided by 20 will give you 5. So both the points we will join. When we join both the intercepts, we get a curve or we get a line which is downward sloping. So this line is showing you the various combinations of labor and capital which the firm can hire with the given cost and given price of the factor inputs. Okay, we have just seen that the slope of the isocost line is what? We say it is price of labor, which is W, divided by the price of capital, which is R. So it will be, what is wage? What is the given wage to you? It is 20. What is the given R to you? 10. So 20 divided by 10, of course it carries a negative sign. Negative sign means that if the curve or your line is downward sloping, so 20 divided by 10 will give us minus 2. On this isocost curve, as we have just said, this blue line, this downward sloping blue line that you can see is showing that the cost everywhere on this isocost line will remain 100. Okay, maybe different combinations of labor and capital, but the cost will always remain 100. Okay, as costs increase, you move to a higher isocost. This isocost line will shift upward if your cost, this from 100, let us say your cost now becomes 200. This means your cost line will shift outside. If your cost reduces, cost line will shift inside. Okay. Also, if there is a change in price of any one factor input, let us say the price of labor changes, this and price of capital remains constant, then there will be a shift in which axis? The shift of the isocost line will take place on the labor axis, on the axis on which we are measuring labor. Okay, for example now, the price of labor remains constant, but price of capital, which is R, changes. So, where will the isocost line now rotate? It will rotate on the k-axis or the y-axis. Okay, this is again, as I told you, very similar to the budget line which we made of the consumer. Okay, so as we are seeing, this higher cost represents a higher isocost line. So if your cost, let us say, increases from your budget as a producer, increases from 100 to 150. Then we will see, keeping the price of labor and price of capital constant, your budget, you will be able to afford more of both the inputs. So your isocost line will shift outside. So these are all giving you examples that how isocost lines are shifting outside when there is an increase in the cost. It will be vice versa. The lines may move from green to red to yellow to blue inwards if the cost is declining. If the cost is increasing, we will shift the lines shifting outside. Right. Similarly, I have just told you that how the price of labor and price of capital will also change the shape of your isocost line. Okay, now coming on to the important question. Till now what we have talked about the technical aspect of it, that how much a producer can produce by given labor and capital, what is the how much the firm can hire with the what various combinations of factor inputs can be hired by the firm given the cost and the price. But what we have to understand is, from the producer's point of view, is that he needs to ask a question, or he needs to decide that, okay, I know that these are the various combinations of labor and capital I can hire. I know that by employing so much labor, so much capital, this is the output I can produce. But tell me, which is the right combination of labor and capital which I should hire? Okay, so that is called as the decision making for the producer, or optimum input combination which you have to decide for the producer. Okay, now any firm, as we talk about a consumer and we say he's rational because he intends to maximize utility. Similarly, a producer is said to be rational when he is maximizing his profits. So, maximization of economic profits is the prime objective of any firm. Okay, and in order to derive these profits, we need to know two things. One, what is the cost the firm is incurring? That is, total cost is equal to W into L plus V into K, means wages, cost of labor plus the cost of capital. Now, if the firm produces, let us say, only one input, only one output, one type of a product, the total revenue will be equal to the price of the product multiplied by the output. We have already seen earlier that total revenue is what? Total revenue is equal to price multiplied by the number of units the firm is going to sell. And what is going to be the profit? Profit is basically the difference between this revenue that we are talking and the cost which we are estimating. So economic profit is the difference between firm's total revenues and total economic costs. So if pi is your economic profits, we will say it is equal to what? P into Q minus the total cost. So this will give us our profits. Now from a firm's point of view, there are two, it would like to minimize the cost. Why? Because if it's a small firm, if we are assuming, the firm will not be able to influence the market price of the product. So in order to get a greater share of profits, the firm's objective would be to reduce the cost which it is incurring on the inputs that it is using. Right, therefore it would like to decide that what is that combination of the inputs which cost me the least. Okay, so in order to find this, the least cost combination of inputs, that is, I want to know that how much of labor and capital I should employ so that my inputs cost me the least. In order to do that, what we do is we combine isocons and isocost lines. Okay, we combine isocons, which represents the various levels of output, and isocost lines, which represents the various combinations of inputs with a given cost. And this will help us to determine the least cost combination. Okay, now what is the idea behind it? The idea basically behind it is to find the lowest isocost line that allows production on a given isocont. Okay, that is, I know that this is this is what I wish to produce. This is the number of units I wish to produce. I need to produce Q1 amount of total output. Okay, now let me know, to produce that Q1, what should be the least cost combination of inputs? How much of labor and capital I should employ so that I get Q1 level of output, as well as the cost which I am spending on these two inputs is also the least. So for that, we try to see that which is the lowest possible isocost line which allows you to produce that given level of output. And where does this combination take place? It occurs where the isocont and isocost lines become tangent to each other. That is, the isocost line, which is downward sloping, touches the highest possible or the given isocont curve. The point where they become tangent is called as the optimum input combination, or for the firm, that is the right point. where it is producing the desired level of output, as well as the cost it is incurring on labor and capital is also the minimum. So what we know is that when we are saying that isocont and isocost line should become tangent, means tangency implies what? We've already discussed about this tangency when we did your consumer behavior. Tangency implies that the slope of both the curves become equal. Slope of both the lines or both the curve become equal. What two things we are trying to equate? We are trying to see the tangency between what and what? We are trying to see the point of tangency between the isoconts and the isocost. And learners, what is the slope of the isocost line? We have just seen the slope of the isocost line is price of labor divided by the price of capital. If price of labor is wages represented by W, R is the price of capital represented by R, this means that the slope of the isocost is W divided by R. What is the slope of your isocont? We have discussed in the previous lecture, which is given by marginal rate of technical substitution. It is equal to MPL upon MPK. That is marginal productivity of labor divided by the marginal productivity of capital. So the slope of isocont is given by MRTS, slope of isocost is given by W by R. And where do we say the optimum combination occurs? Where both these slopes become equal. That is, W by R becomes equal to MPL divided by MPK. Or the price ratio of the inputs becomes equal to the ratio of the marginal products. W by R gives what? It is telling you what is the price of the factor inputs. So the price ratio, when it becomes equal to the ratio of the marginal products of these factor inputs, we get what is called as optimal combination. Let us see the graphical representation of this. Let us say we want to produce Q1 units of output given by this isocont Q1. The slope of the total cost or your isocost is given. This is the equation W into L plus R into K. The slope is W by R. As we have just said, the point of tangency between isocost and isocont will give you your equilibrium. Now, what has been given to you? You need to produce Q1 level of output. So this isocont is given to you. What we will do is we will superimpose this particular isocont on the various isocost lines which are available to the firm, given by here in this graph, which we are going to just see as given by TC1, TC2 and TC3. So let us see that what I was telling you. Let us see these are the three isocost lines given to the firm. TC1, TC2, TC3. So the firm knows that these are the various costs which I have, which I can incur with the given in price of inputs. Let us say he says that if my given cost is 100, this is my isocost line. When my given cost is 150, this is my isocost line. When my given cost is 200, TC3 is my isocost line. So various isocost lines are given to you. But what is the objective? The objective is to produce Q1 given by one isocont at the least possible cost. So for that, what we will do is we will superimpose this Q1, this isocont which represents the Q1 level of output, and see where is this particular isocont getting tangent to which isocost line. Right. Now, if you see, this Q1 is getting tangent to TC2. Right. TC3 would be a higher cost for it. Whereas TC1, if it goes, it means it will be producing less. Why? Because this TC1 corresponds to a lower level of isocont. So this Q1 level of production can be achieved by spending or by being on this TC2 line. Right, and it TC2 line, which is your isocost line, is becoming tangent to your Q1 at point E. showing that the firm should employ OL star amount of labor and OQ star of capital that will give them the minimum possible cost and will also produce Q1 level of output which it intends to produce. So by this, the firm will be minimizing the cost of producing Q1. So this is one situation. The other situation can be where the cost is given to us. Where the cost is given to us. In the previous situation, we were given what? Output was given to you and we were asked that tell us that what is the minimum cost to produce this given level of output. So what did we do? Output was already given to you. Your Q1 was given to you. You superimposed this Q1 on various ISO cost lines which the firm had generated with given different level of cost. And we saw where this ISO becomes tangent to the ISO cost. The other situation is where you are being asked that tell us that with this given level of cost, what is the maximum output I can or the firm can produce. See the difference? There, output was given to you. You had to minimize the cost to produce that given level of output. Here, cost is given to you and you are asked to maximize the level of output. How will we do it? Let us see this. Now this cost has been given to you. This represents one ISO cost line. So cost is given. What do we have to find? We have to find that maximum level of output which I can produce with this given ISO cost line. Condition will still remain the same. That is the tangency between the highest possible isocont and the given isocont. Okay, so what we will do now is we will superimpose various types of isoconts. Each isocont is representing different level of production or output. Let us say Q1, Q2, Q3 is the various levels of output that you are there and you wish to know that what is the maximum level of output I can produce with this given cost. So what have we done? Basically, with this given ISO cost line, we have imposed your ISO quant map and see that to which ISO quant, which highest possible ISO quant, this ISO cost line is tangent to. So Q1, Q2, Q3 are the three levels of output. This ISO cost line is given to you, to which ISO quant the line is tangent to. It is tangent to Q2 level output level or Q2 isocont. Okay, this means that the highest possible level of output the firm can produce with this given cost is Q2. And for that, the firm will have to employ K star of capital and L star of labor. Right? So this is maximizing output with given cost. Now another important thing which we need to discuss from this is the firm's expansion path. We have just understood that the firm decides by either keeping the cost constant and deciding what is the highest output it has to produce, gets a tangency between the ISO cost line and the isocont, or it says that these are the various, this is the output level which I want to produce, tell me which is the minimum cost. So what did we do at that time? To various ISO cost, we imposed our given isocont, but again tangency rule remain the same. So this means that a firm should know that if it wants to expand, what is the various combination of inputs it should be using so that it is doing at an production at an optimum level. That is given by the expansion path. So if we do a similar analysis of for any level of outputs, keeping the input costs constant, that is there is no change in W and R, we will get an expansion path. That is, if Q keeps on increasing and the W and R, that is the price of labor and price of capital, are constant, various cost minimizing choices can be traced out. So and when you trace out these choices and when you join all these cost minimizing combinations of inputs, the line or the path which you get is called as the expansion path. So what is an expansion path? Expansion path basically is the set of cost minimizing input combination of a firm that a firm will choose to produce various levels of outputs, keeping of course the price of inputs constant. That is, if a firm wants to produce a set of all the cost minimizing input combinations, that is what for example, at one situation you had L star K star. This is one combination which the firm can use if it wants to minimize the cost. Similarly, if it increases the cost or if it increases the level of output which it wants to derive, then it will get to a new equilibrium where you will get another level combination of labor and capital. Then again it wants to expand, it will get another level of labor and capital where both isocont and isocost are tangent to each other. When you join all these points, the path which you get is, or the curve which you get, is called as an expansion path. Okay, let us see. This is an expansion path which we are deriving. Let us say these are the various isoconts which are there. This is an isocont map. Each Q1, Q2, Q3, Q4 representing a particular level of output which the firm can produce. Okay. Now, the firm, as it moves higher on the isocont, the output produced increases. Now, in order to draw the expansion path, we will find the tangency of these isoconts with their respective isocost lines. So, you see that to Q1 you have TC1 which is getting tangent to Q1, TC2 is tangent to Q2, TC3 is tangent to Q3, TC4 is tangent to Q4. Tangency means what? That the slope of the given isocost is equal to the slope of isocont. So when we join all these equilibriums, given tangency of Q1, Q2, Q3, Q4, which we have marked as A, B, C, D, when we join all these points, this path, this line that you get is called as an expansion path. The features, if you see, we see that the expansion path is sloping up to the right. It is sloping upward. Okay, an expansion path means that you will be needing more of both the resources if you want to increase the level of output. For example, if you are moving from Q1 to Q2 or from point A to point B, you are requiring more of labor as well as more of capital. Similarly, if you move from C to D, you require more of labor and more of capital. So this expansion path is telling that if the firm is on this expansion path, there is a tangency between the isocost line and the isocont line. All these tangency points are showing the optimum input combination with which the firm's cost is getting maximized. Okay, so now let us just do a small self-test, just a recall to whatever we have done. The first question to you learners is that dash is defined as the locus or joining of the points of tangency between the isocont and the isocost lines. When you join the point of tangency between isoconts and isocost lines, what is that called as? It is called as the expansion path. Second, the point of equilibrium of the firm is the point of tangency between dash and dash. When does the firm find its optimum input combination or its equilibrium? With the tangency of what two things? Isocont and the isocost. So let us just quickly summarize whatever we have done today. We have said that ISO cost line, which is analogous to your budget line of the consumer, it shows all input combination that a firm can purchase with the given outlay or with the given cost and given input prices. The optimum combination is achieved between the tangency of the ISO cost and the ISO quant. And expansion path is basically the locus of the equilibrium points which we get by changing ISO cost of the producer. That is, if the cost lines are shifting, so you will get to a higher level of output. So the point of tangency of ISO cost and various ISO quants, when you join that point or join those points, the curve or the line that you get is called as your expansion path. So learners, this finishes off with our third unit of production analysis, where we have explained the short run and long run production functions. We have talked about law of variable proportion. We have talked about returns to scale, as well as we have seen how the firm decides the optimum combination of factor inputs it should utilize in order to minimize its cost. Why? Because the firm, being rational, would like to maximize the profit. I hope this has been an enjoyable experience or enjoyable unit for you. The next unit we will be talking about the cost. Thank you very much. Till then, happy learning.